Hello, chemistry students. I'm going to crank out problem 20 real quickly, and here it is. And it's really not much different than most of these other problems that we've had once you see it worked out. And it's basically a stoichiometry problem and a molarity problem. And that's it. And so first off, it wants to know, the question is, what is the molarity of this stuff? And it gives us the volume. So molarity is equal to moles of the solute over the volume in liters. Well, we have the volume in liters there. It's in milliliters, so it's 0.04418 liters. So boom, we want this. All we need is the moles of this. Okay. Well, you're given, there's an error there, it didn't translate when I copied and pasted very well. So you're given this here, and you're given this here. So one of these two is the limiting reactant. Okay, so what you could do is you can take one of these here, you can take this, let's take this. Okay, and then let's turn it to moles. So we need the molar mass of oxalic acid, and that is 90.038 grams per mole. So we put the 90.038 grams here for the grams to cancel, 1 mole here. Okay, and then when we divide those, we get 0.0206. So 00659 moles of oxalic acid, which is H2C2O4. Okay, well now we need to take that and do our stoichiometric ratio, because we want this stuff, right? So 0.020659 moles of CH2C2O4. And stoichiometric ratio is want over have. We're switching the comments. We want this. We use the balance ratios. 2 over 2 want over have 5. So it's 2/5 is our ratio. 2 KMNO4 over 5 per every 5. That's a 5. That's terrible. Apologize. H2C2O4. That cancels. So we basically multiply by 2, divide by 5, and we end up with 0.00802,636 moles of KMNO4. Now, what we need to do is to see if this other stuff right here, what's that going to produce us? Is this excess, or is this the limiting, or is this the limiting reactant? And I'm going to, it just has a feel that this is that. But you can always check to see if this is the limiting reactant if you check the sulfuric acid. So there's the sulfuric acid. So if you wanted to check that, we can. So what we can do is, this is probably going to be our moles, which would go into here, and you divide it by this, and you get your molarity. But we better make sure, just to check that it's the limiting reactant. So we have that many milliliters of 1 molarity acid. So this is kind of a separate, we'll leave this here, and we have 1 molarity, molarity equals moles per liter, and we have 1 equals moles, which we don't know, over X, which is 0.025 liters. And when we multiply that, that's 0.025 moles of H2SO4. Now we need to do our stoichiometric ratio for this. Okay, now let's look up here. And what's our ratio for this? It is want over have, 2 over 3. Okay. 2 over 3. When we do that, 0.0166667 moles of KMNO4. So your question is, which one of these two is smaller, this one or this one? This one is. So if you remember our limiting reactant, when we have to do that, the smaller one is how much we actually will get to make. We don't get to make this because we're going to run out of the other ingredients. So this is what we produce. So this is the number. We were correct in using this. So what was this? This was not, we don't even need that. We just use this. So our molarity is 0.00802,636 moles divided by our volume, which is 0.04418 liters. And when we do that, I get 0.1816 molarity. And I think this one wants four decimals. So 0.1816 molarity. And that's it. Cool.